Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So I was actually teaching the structure of the atom, which is the 4th chapter of 9th standard science subject. So please do refer the previous videos and then refer this particular video to understand this particular 4th chapter. So the next concept which is there in this particular chapter is that atomic number. So what do you mean by atomic number? Atomic number is the number of electrons or number of protons. So how many number of electrons or protons are there defines the atomic number of that particular element. So for example, if you consider hydrogen as your element, then one atom of hydrogen will contain one electron and it also contains one proton. So why I am writing number of electrons or protons? Because electrons and protons will always be equal in number, because the charge of one particular element or one particular atom should always be balanced. So that's why the negative charge, the net negative charge of electrons, all the electrons will be balanced by net positive charged protons. So if you have two electrons, then there must be two protons. There cannot be extra proton or there cannot be an extra electron in an element. So how many electrons are there? That many protons should be there. So this particular number of protons or number of electrons will define the atomic number of a particular element. Only based on this particular atomic number, the characteristics, the chemical characteristics of an atom varies. If you consider 1 as your atomic number, then that is actually related to hydrogen atom. So now if atomic number is 2, so this particular atomic number 2 represents helium atom. So now if you consider atomic number 3, then that corresponds to lithium atom. So on in the periodic table, every elements have unique atomic number to it. That is, every element has fixed number of electrons and protons, which defines the atomic number of that particular element. So if hydrogen has one electron and one proton, then that particular hydrogen has atomic number 1. Similarly, any element if you take in the periodic table, so that atomic number of that particular element is fixed. That is, number of electrons and number of protons will be fixed in that particular element, which is actually corresponding to its atomic number. And this particular atomic number is denoted with the symbol Z. So what do you mean by Z? Z is actually the atomic number, which can be the, so what is Z? Z is actually the atomic number of a particular atom. So I'll just write atomic number of an element. So if I write an element, let's say hydrogen, and at this particular position, if I am writing a particular number, then that actually represents the atomic number of that particular element. So now I am writing 1 over this particular position. So this 1 represents that this is the atomic number of hydrogen, and that particular atomic number of hydrogen is 1. Similarly, if I consider helium, then I will write 2 in this particular position, because helium has 2 electrons and 2 protons in it. So atomic number of helium is 2. So at this particular position, if you are writing, then that is the place where atomic number of that particular element is written. Similar to atomic number, there is one more terminology which is known as atomic mass number. So what do you mean by mass number? So mass number means, roughly if you have to have an idea about atomic mass number, then atomic mass number is the total mass of a particular atom. So that's why it is known as atomic mass. So how to calculate mass of an atom? So I have explained this in previous videos while discussing about atomic mass, where carbon-12 isotope of carbon is actually considered as the reference element. Based on that particular value, other elements got their atomic mass unit. So if you want more explanation about this, you can refer my previous video where I have explained about atomic mass number. Simply, if you want to remember what is atomic mass number, then it is the total weight of that particular atom. So for example, if you are considering hydrogen, then this particular hydrogen contains one electron and one proton. So this particular proton will be there in the nucleus of this particular hydrogen atom. So proton will be in the nucleus. So nucleus will be in the center position of that particular atom. So in that particular nucleus, you will have number of protons and number of neutrons. And in hydrogen atom, number of neutrons is 0. So there is no neutrons present in hydrogen. Only protons are only one proton is present in the nucleus of hydrogen. So the total mass of hydrogen is the mass of nucleus of that particular element or that particular atom. So if you are considering electrons mass, then electrons mass is 2000 times lesser than, approximately 2000 times lesser than the mass of proton. So if you consider mass of proton and mass of electron, then mass of proton is 2000 times more than electron, and in higher elements where neutrons also coming to the picture, there neutrons mass and proton mass are comparable with each other. But when you compare the mass of neutron or the mass of proton with the mass of electron, then electron mass is 2000 times, approximately 2000 times lesser than the mass of proton or neutron. So that's why most of the mass of an atom is determined by the number of protons and number of neutrons present in that atom, because protons and neutrons are much more heavier than electrons. So that's why mass of electrons are ignored, and the mass of protons and mass of neutrons which are present in that particular atom is considered as the atomic mass of that particular atom. So here mass of all protons present and mass of all neutrons present in an atom will account for atomic mass of an atom. So now what do you mean by atomic mass number? So when you consider atomic mass number, at that particular time you are taking number of protons and number of neutrons. So now if you are including this number into picture, that is atomic mass number, then this particular number is the sum of protons and sum of neutrons. So for example, if I consider helium, then helium has 2 electrons, 2 protons, and this particular helium has 2 neutrons. So now what is the atomic number of helium? So atomic number of helium will be 2, because it has 2 electrons and 2 protons. So either you should consider number of electrons or number of protons to determine the atomic number of a particular element. So now if you want to determine the atomic mass number of this particular element, of this particular atom, then helium atom consists of 2 protons and 2 neutrons. So what will be the atomic mass number? That will be 2 plus 2. So 2 plus 2 will be 4. So atomic mass number of helium is 4. So now if I write a number at this particular position of an element, then that actually represents atomic mass number. So when I was actually explaining about atomic number, I told at this particular position if you are writing a number, then that is accounted for atomic number. So this atomic number is actually denoted by Z, and this particular atomic mass number is denoted by A. So for a particular element, let's say X element, if I write A over here and if I write Z over here, this Z actually determines the atomic number of this particular X element, and this particular A determines the atomic mass number of this particular element. Now helium has 2 as its atomic number, so I will write 2 at this particular position, and helium has 4 as its atomic mass number, so I will write 4 at this particular position. If I write He 4 and 2 in this particular position for He, then that represents this helium has 2 atomic number and 4 atomic mass number. So now by looking at these particular numbers, you can determine how many electrons and how many protons are there in helium atom. So here 2 is there, so that indicates 2 electrons are there and 2 protons are there, and here 4 is there. So now since atomic number is 2, you can actually subtract this particular 4 with 2 and the remaining number will be 2. So this is the number of neutrons present in that particular atom, because atomic mass number, that is 4, is the sum of number of protons and number of neutrons. So this particular 4 is equal to number of protons present in the atom plus number of neutrons present in that atom. So N represents neutrons. So number of protons plus number of neutrons will give you 4. Now here 2 is number of electrons, and we know that number of electrons and protons are equal in an atom. So that means here 2 protons are there in this particular atom. So now you substitute 2 in this, and you don't know what is number of neutrons. So bring this 2 to LHS, so then it will become 4 minus 2, that is 2. So number of neutrons will be 2. So this is how you should calculate number of neutrons. So any element, then Z will be the atomic number and atomic mass number is indicated as A. So A represents atomic mass number of a particular element. So now A is always equal to Z plus number of neutrons present in that particular atom. So now if you want to calculate number of neutrons, you can just bring Z to the LHS. So A minus Z will give you the number of neutrons present in that particular element. So this might be asked in your exams. They might give some elements and they might give the atomic mass number and atomic number of that particular element, and they might ask you to calculate the number of protons, electrons and neutrons present in that particular atom. So just by looking at the atomic number, you can tell how many electrons are there and how many protons are there. To calculate number of neutrons, you should actually take the atomic mass number and subtract that with atomic number. So you'll get the number of neutrons present in that particular atom. So coming to the next concept which is there in this particular chapter, that is isotopes. So what do you mean by isotopes? In nature, a particular element exists in different forms. So if you should actually sum up all those forms to get 100% of that particular element in the nature. For example, if you consider hydrogen, then this particular hydrogen exists in 3 particular forms. That is, one is protium, the other is deuterium, and the third one is tritium. So now if you consider protium, so protium is the normal hydrogen element which is abundant, which is in more percentage compared to other two, deuterium and tritium. Protium has 1 atomic number and 1 mass number. That is, here atomic number is fixed, but mass number is 1, and this particular mass number varies. So now if you consider deuterium, so this particular deuterium contains 2 as its atomic mass number, but atomic number is fixed. That is, 1 electron and 1 proton are fixed for all kinds of isotopes of hydrogen. So now the third one is tritium. So in tritium also, the atomic number of hydrogen is 1 itself. So this atomic number defines which element we are actually discussing about. So that is, here we are discussing about hydrogen. So that's why all hydrogen isotopes will have same number of electrons and protons, but mass number will be varied. So how is it possible? So protons will be fixed, but the number of neutrons will go on varying. Based on that, we will actually see that there is change in atomic mass number. So here you can see 1 electron is there, 1 proton is there, but 0 neutrons are there. But in this particular case, 2 atomic mass number is there. That means 1 proton is there and 1 neutron is there. Because here you can see atomic number is 1 itself. So proton is only 1. Now to calculate number of neutrons, you can subtract the atomic mass number with atomic number. That is 2 minus 1. So 2 minus 1 is 1. That means 1 neutron is there. So here 0 neutrons were there. Here 1 neutron is there. In tritium, the atomic mass number is 3. So that is 3 minus 1 will be 2. So 2 neutrons are there in this particular hydrogen. But number of electrons and protons are same for all these 3. That is, all these 3 isotopes have 1 electron and 1 proton in it. But number of neutrons are going on increasing. So what is the point in discussing about these points? Because hydrogen in the nature exists as protium, deuterium and tritium. So now if you consider the percentage of isotopes of hydrogen, then protium is in maximum percentage. Almost more than 99% of hydrogen is in the form of protium, and very less percentage of hydrogen is in the form of deuterium, and very less percentage of hydrogen is in the form of tritium. That is, 99%, more than 99% of hydrogen is available as protium. So that's why we actually conclude that this particular isotope of hydrogen, that is protium, is the actual hydrogen element because it contains one atomic mass number and one atomic number, because that is abundant in nature compared to deuterium and tritium. So that's why protium atomic mass number itself, so protium atomic mass number itself is considered as the atomic mass number of hydrogen, because most of the hydrogen exists in the form of protium, not in the form of deuterium and tritium. Only very less percentage of deuterium and tritium are present in the nature. More than 99% of hydrogen is present in the form of protium. So that's why this protium atomic mass number itself is assigned as the atomic mass number of hydrogen. But when you consider another example, let's say chlorine. So chlorine exists in two isotopes. So now if you are considering chlorine, one particular isotope of chlorine is chlorine 35 and the other isotope of chlorine is chlorine 37. So now to determine the atomic mass number of chlorine, so 75% chlorine has 35 as its atomic mass number. So 25% of chlorine exists as Cl37. That is, the isotope of the second isotope of chlorine has atomic mass number 37. So here this particular chlorine 35 and chlorine 37 exists as 3:1 ratio in the nature. That is 75% is in the form of Cl35, that is this particular chlorine isotope has 35 as its atomic mass number. So 25% of chlorine exists as chlorine 37 isotope. That is 37 is the atomic mass number of the second isotope of chlorine. So now here if you are considering hydrogen, then more than 99% of hydrogen exists in its first isotopic format itself, that is protium. So that's why roughly we came to a conclusion that atomic mass number of protium itself can be the atomic mass number of hydrogen. But now if you are considering atomic mass number of chlorine, here 75% is only there as chlorine 35. So you cannot consider 35 as its atomic mass number, because remaining 25% of chlorine is in the form of second isotope, that is chlorine 37. So now to calculate the atomic mass number of chlorine, you should actually consider both the isotopes. So if you consider first isotope of chlorine, that is chlorine 35, 75% abundance is there of this particular first isotope of chlorine. Now if you consider Cl37, then 25% of abundance is there of this particular Cl37. Now both of them have different atomic mass number, so you should average out the atomic mass number of both the isotopes, and in general you should give the atomic mass number for chlorine. So now if you want to calculate atomic mass number of chlorine atom alone, then you should consider atomic mass number of both the isotopes of chlorine. So the first isotope has 35 as its atomic mass number, that is 75% of it. So the second isotope of chlorine is chlorine 37, which has 37 as its atomic mass number. So 37, how much percentage abundance is there? 25% abundance is there for chlorine 37 isotope. Now you should add up these two so that you will get the average atomic mass number for chlorine. So now how to express 75%? So 35 into 75% will be 75 by 100 plus 37, that is chlorine 37 isotope has 25% abundance, so it will be 25 by 100. So now when you calculate this, so it will be 35 into 75 plus 37 into 25 divided by 100. So both have same number in the denominator, so directly you can add the numerators. 35 into 75, this will be in one particular bracket, plus 37 into 25, this will be in another bracket. Now if you solve this, you will get answer as 35.5. So 35.5 U, this is actually unified mass unit, or you can generally call it as atomic mass unit. So this is the general atomic mass unit of chlorine. So there is one more last concept in this particular chapter, which is known as isobars. So what do you mean by isobars? Any two elements or any two atoms which has same mass number but different atomic number. So same mass number is there, same atomic mass number is there, but different atomic number is there. So such two atoms can be known as isobars. So now if you consider calcium, one of the isotope of calcium, that particular calcium has 20 as its atomic number and 40 as its atomic mass number. So this is actually atomic mass number, which is denoted as A, and this is 20, that is Z, that is atomic number of calcium. So now if you consider argon, argon has 18 as its atomic number. So atomic number of argon is 18 and 40 as its mass number. Here argon 40 and calcium 40 can be the example for isobars, because calcium has 20 atomic number and argon has 18 atomic number. But mass number, when you consider the mass number of calcium and argon, both have same. So what does this interpret? In this particular calcium, there are 20 protons and 20 neutrons present. But here in argon, 18 protons are there and 22 neutrons are there. So that's why here mass number of both argon and calcium are same, but atomic number of calcium and argon are different. So if you have same mass number and different atomic number, then it is known as isobars. But in the case of isotopes, atomic number will be same, but mass number will be different. In isobars, atomic mass number will be same, but atomic number will be different for isobars. So this is all there in this particular chapter, and this concludes the chapter. So in my next video, I'll be teaching the exercise questions which are there in this particular chapter. So until then, you can watch my previous videos. So like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.